Hello students, Professor Nugent here. Let's talk about difference in difference for policy analysis. In the event of a natural experiment or a quasi-experiment, we can use pooled cross-section with difference in difference to evaluate the effect of a policy. A natural experiment is when some exogenous event, such as a change in government policy, changes the environment in which individuals, family, firms, cities, etc. operate. An example of this method might be to look at what the effect of the Affordable Care Act had on healthcare consumption. So you had a change in government policy, and we want to know how that change in government policy affected how people consume healthcare. We require treated and control groups before and after the intervention. So with this idea of the Affordable Care Act, we can use this method because different states implemented the Affordable Care Act to different extents. And so you have a treated and control group and can evaluate on the margin what the effect of the greater extent of the implementation of the Affordable Care Act had on how people consume healthcare. And what matters here, what the mechanism is for impacting household behavior, is that now many more people are covered under health insurance. And usually this variation in state-to-state coverage happened under the Medicaid expansion. Different states expanded Medicaid differently. And so you had this natural experiment where you had some states with no Medicaid expansion, other states with a lot of Medicaid expansion. You had treated and control groups before and after the intervention, where the intervention is the Affordable Care Act. And what we want to do is compare the difference between the groups over time to assess the effect of the policy. So we're going to look at what does healthcare consumption look like in a state that did not expand Medicaid under the Affordable Care Act. How does the healthcare consumption over time look like in the state that did not expand, to how healthcare consumption looks like over time in the state that did expand Medicaid under the Affordable Care Act. All right, so this is the broad concept, and again, we need treated and control group, and typically the sample consists of 4 groups. You'll have control before, control after, treated before, and treated after. We also need some additional assumptions so that we set up our natural experiment, our quasi-experimental method with difference in difference correctly. The additional assumptions are the following. The first, that intervention is unrelated to the outcome at the baseline. So the allocation of intervention is not determined by the outcome. If we're thinking about the Affordable Care Act, what we want to know is that if we think about 2 states that are relatively similar in their healthcare consumption and other demographics, that the choice to implement Medicaid is not related to how much healthcare consumption is currently taking place. And that choice to implement Medicaid expansion across states is not in any way systematically related to current healthcare consumption. Parallel trends is really the critical assumption to ensure the internal validity of difference in difference models, and this is really the hardest to fulfill, it's the hardest to test. Parallel trends requires that in the absence of treatment, so in the absence of intervention, the difference between the treatment and control group is constant over time. So in our example of the Affordable Care Act, we're thinking about the difference in the absence of the Affordable Care Act, the difference in healthcare consumption between two states is constant over time. And this is hard to test because we don't really observe what the intervention state looks like without the intervention. But there are ways of theoretically getting at parallel trends, and we may have some time later in the course to think about this. Next, we require that the composition of intervention and control groups or other comparison groups, that the composition is stable for repeated cross-sectional design. All right, so we're thinking about the distribution of demographics and so on is stable. It's not changing across groups over time. And finally, for identification of the treatment effect, identification of, in our example, the effect of expanding Medicaid under the Affordable Care Act and healthcare consumption, we require no spillover effects. No spillover effects means that the treatment or the intervention has no effect on the control group. So if we have two neighboring states, if we think about, for example, New York and New Jersey, and New York expands Medicaid, New Jersey does not, then we should see that only the effect of the expansion on Medicaid in New York affects people living in New York and does not in any way affect the way that people who live in New Jersey consume health care. So these are our assumptions that we require so that we can use difference in difference to identify a treatment effect. Now let's write down the model. Let's write down the model. If we let C be the control group and we let T be the treatment group or intervention group, I'm going to have a variable by the name of treat, which is, this is a binary variable that is equal to 1 if the observation, if the unit is in the treatment group, and 0 otherwise. We have another binary variable, D2, which is equal to 1 if in second period, so we're thinking about data with 2 periods, 2 years or 2 months, something like this. And the second period is post policy. All right, so we have data on 2 periods. The first period is pre-intervention. The second period is post-intervention. Then we can write the simple difference in difference equation as the following. Y is equal to beta naught plus delta naught times D2 plus beta 1 times treat plus delta 1 D2 times treat. plus U. This is the very simple difference in difference equation. And the difference in difference estimator is delta 1 hat, and delta 1 hat represents y2 t bar, so this is the average of the outcome variable in the second period for the treated group, minus y2 c bar, the average of the outcome variable in the second period for the control group, minus y1 t bar minus y1 c bar. So you can see we take the difference of the average of the treated and control group in the second period, subtract the difference of the average in the treated and control group in the first period. And this difference in difference estimator gives us the average treatment effect. This is the average treatment effect, which is the effect of the treatment or policy on the average outcome of y. Now observe that this does give us the initial effect that we wanted, which was to compare the difference between the groups over time to assess the effect of the policy. And by doing so, we are able to account for differences or things that are happening to both groups that may matter, for example, healthcare coverage, and we can difference that out. Okay, so really what we get is the effect of the policy by comparing the difference between the groups over time. Now typically we will also control for other variables in the difference in difference equation for proper causal inference. So we'll add additional covariates into this expression, and then the difference in difference estimator no longer simplifies to this expression, but it has the similar interpretation, which is to compare the difference between the groups over time to assess the effect of a policy. That's it for difference in difference. Stay tuned to the next video. We'll look at 2-period panel data.